In this video, we're going to be talking about trigonometric functions of special angles. And those special angles that I mentioned before, they're half of the 90 degrees and a third of a 90 degrees and 2/3 of a 90 degrees. We're going to talk about sines, cosines, and other trig functions of them. Now let's write them in radian measure. Let's get used to seeing them in radian notation. So 45 is pi over 4, 30 is pi over 6, and 60 is pi over 3. Okay, so first we're gonna look at 90, 60, 30 triangle. It turns out that the proportions of the sides in this triangle are very special. And we're gonna start with equilateral triangle, where all three sides are the same and all the angles are the same. So we have a 60, 60, 60 triangle. So angles are the same. So since angles are the same, opposite sides are also the same. So let's say we have a line, a bisecting line that cuts this triangle into exact halves, two halves. Okay, so now this 60-degree angle becomes 30 and 30. And let's say that this side now is has two pieces, two equal pieces. We call them S, okay? We don't know what measure they are. We'll just say they're S and S. Well, that means that this side is 2S and this side is also 2S. So now we know two sides. If we look at this triangle now, it's a right triangle because when this when we have two equal parts, this line will be perpendicular to the base of the triangle, and we're gonna have a 90-degree angle formed right here. Okay, so we can apply our Pythagorean theorem to figure out the length of this side. So Pythagorean theorem says a squared plus b squared equals c squared. So we don't know this side. We will call it x for now. So x squared plus s squared equals 2 times s squared. So that's Pythagorean theorem. Okay, so let's go ahead and solve it for x. X squared is s plus s squared is 4s squared. Now, in order to isolate s squared, x squared, we're going to subtract s squared on both sides, and we're going to have x squared equals 3s squared. Now to unsquare x, we're going to put the square root. So x is a square root of 3s squared. So I'm going to break them into separate square roots because the square root of s squared is s. I can perform this. So x is square root of s. So the length of the side will be now I know the length. I will write it. I will write it as square root of 3 times s. Okay, so if we have a 60, 30, 90 triangle, that's the relationship in those between those sides or among those sides. So the shortest side has a length of S. The longer leg adjacent to 90 degree is square root of 3 times S, and the hypotenuse is 2S. So using this triangle now, we can actually figure out the 6 trigonometric functions of angles 60 and 30. So for sine, let's say of angle 60, we're going to start with 60. Sine is opposite over hypotenuse. So we're going to have square root of 3 times s divided by 2 times s. So s will cancel out, and we're going to have square root of 3 over 2. So the sine of this of 60 degrees is always going to be square root of 3 over 2. And it doesn't matter since the side length of the side cancels out. It doesn't matter what triangle, the size of the triangle, as long as it's a 60, 30, 90 triangle. The sine of 60-degree angle is always going to be square root of 3 over 2. Now for the cosine of 60, we have adjacent over hypotenuse, 2s. So again, s and s canceled. We do have 1 here that's left. So cosine of 160 is, of 60 degrees is 1 over 2 always. And the tangent of 60 is it's opposite over adjacent, so square root of 3 times s divided by s. And again, s and s cancels out. We have 1 left here and there actually, but we don't write it. So that's square root of 3 over 1, or just the square root. So these are, again, you have to guys memorize them. They're functions of 60 degrees. So this is trig functions of 60-degree angle, or pi over 3 angle. Okay, so now let's do the same thing for a 30-degree angle. So cosine, I'm gonna actually cut it out. Cosine of 30, well, what should I start with sine? But anyway, cosine. Cosine of 30 is adjacent over hypotenuse. So it's going to be square root of 3 times s over 2s. And s will cancel out. And we have square root of 3 over 2. Now for the sine of 30, we have for the sine is opposite over adjacent, so over hypotenuse, sorry. So it's s over 2 times s. Again, s's will cancel out, and we're gonna end up with 1/2. And for the tangent of 30, for tangent is opposite over adjacent, so we have s over square root of 3 times s. And after we cancel s out, we have 1 over the square root of 3. Okay, so now these, so now these are the functions, trigonometric functions of 30-degree angles. And once we know these 3, then we automatically know secant, cosecant, and cotangent as well, because they're just flips of these 3. Now, or reciprocals to be correct. Now what I want to point out to you is again that sine of 60 is square root of 3 of divided by 2. Cosine of 30 is also square root of 3 over 2. And the same, right? The cosine of 60 is 1/2, and so is sine of 30. And that's what we just mentioned earlier. The 60 and the 30, they add up to 90 degrees angles. That's why the cofunctions are the same. That's what we were talking about before. So keep that in mind, and we are moving on to the next special triangle, which is 90, 45, 45 triangle. So here's our 45, 45, 90 triangle. And again, we're gonna say that this side is S and this side is S, because they are the same, because the opposite angles are the same. Then applying our Pythagorean identity, our side C, we're going to call it x for now, is going to be x squared. Okay. All right, so let's solve it for x. So here we have s squared and s squared. That makes 2 s's squared and x squared equals x squared. So to solve it for x, we need to unsquare both sides. We do it by applying square root, and we have square root of 2 times the square root of s squared. I'm going to separate from under the root, and that equals to x. Square root of x squared is x. And okay, so square root of 2 is irrational number. I'm going to leave it, but square root of s squared is just s. So x equals square root of 2 times x. So this side is square root of 2 times s. Okay, so again, now using these relationships between the sides, we could come up with trig functions for 45-degree angle. So the sine of 45 is, let's choose, it doesn't matter, they're both the same, but let's choose one. So it's the opposite over hypotenuse. So s over the square root of 2 times s. And again, we cancel out s, and 1 stays behind. So that's 1 over the root of 2. But remember that in math, we don't like square roots on the bottom. So we need to rationalize it. And we're going to rationalize denominator by multiplying square root in to the denominator. But we have to do the same thing to the numerator. So we end up with square root of 2 over 2. So that's the sine of 45 degrees, square root of 2 over 2. And then the cosine of 45 degrees, guess what it's going to be? It is the adjacent over hypotenuse. So again, it's s over the square root of 2 times s. And we already know that it's going to end up being square root of 2 over 2. So for 45 degrees, the sine and cosine are the same because this triangle is symmetrical, very symmetrical. So both one side and the other side are equal. So their trigonometric functions are equal as well. And for the tangent of 45, we have the opposite over adjacent. So it's going to be s over s and equals 1. So sine is equals to cosine equals square root of 2 over 2. Tangent equals to 1. And these are our trigonometric functions of a 45-degree angle. Okay, so what does that mean for our circles, like our circular uh, trigonometry or geometry? Well, if you have an angle of pi over 3, and you remember that pi over 3 is equivalent to 60-degree angle, then this is what it's gonna look like when the triangle is inscribed in a circle. And remember, like we mentioned, that no matter um, what the length of the radius is, or this of the side is, these are the relationships between their sides, the proportions of the sides, right? They don't change. So your sine of pi over 3 is still gonna be opposite square root of 3s over hypotenuse, which is 2s, which is square root of 3 over 2. Your cosine of pi over 3 is still gonna be the adjacent, which is s, over the hypotenuse over 2s, so 1/2. And the tangent is still gonna be adjacent over opposite. So s over the square root of 3 times s, which will give you 1 over the square root of 3. And again, we need to rationalize the denominator. I think I forgot to do that last time we calculated it out. So I have square root of 3 over 3. All right, so that's what that means for our circles. Now, in a unit circle, if we are talking about the unit circle, then your radius equals 1 in the unit circle, right? So hypotenuse is 1. And this means that this side of the triangle, it's a pi over 3 angle. So this side would be 1/2. And this side is going to be a square root of 3 over 2. So this point right here would have coordinates of 1/2 and square root of 3 over 2. Right? So this is the x coordinate, this is the y coordinate of that point right there. And for 45, 45, 90 triangle, this side is going to be square root of 2 over 2. And this side is also square root of 2 over 2. And this coordinate of this point would be square root of 2 over 2 for x and square root of 2 over 2 for y. All right, so that's the connection between our special triangles and our right triangle trigonometry. Now, what I want you to think about is if we have an angle of pi over 6, let's say right here. So that's another triangle with angle pi over 6. What would be the coordinates of this point right here? I'll give you a second to think about that. And if you answered square root of 3 over 2 for x and 1/2 for y, you were right. So let's summarize what we learned in this section. So we were talking about angles of 30 degrees, 45 degrees, and 60 degrees. in radians. So these are degrees. In radians, 30 is pi over 6, 45 is pi over 4, and 60 is pi over 3. Okay, now we're gonna write their functions: the sine alpha, cosine alpha, and tangent alpha. Okay, so the sine of 30 degrees is 1/2, and so is the cosine of 60, right? 1/2. And then the cosine of 30 is square root of 3 over 2. And sine of 60 is the same, square root of 3 over 2. And the tangent, well, for 30, it's 1 over square root of 3 or square root of 3 over 3. Tangent of 60 is just square root of 3. Now for pi over 4, we have square root of 2 over 2 for sine, square root of 2 over 2 for cosine, and 1 for tangent. Okay, so start memorizing these now because you are expected to remember these trigonometric functions. Alrighty, and I'll see you in the next video.